Hey everyone, it's been a while since I've posted. I hope you're all well. This is just something that's landed in front of me. It's a tool that I have absolutely fallen in love with. As a chemistry teacher, I was always looking for really good software to be able to draw molecules, but this is not just for teachers, this is actually for students as well. So I'd like you to go to a browser. You can do this on mobile, you can do this on computer, and have a look at MoleView. MoleView is one of the best ways to draw and visualize organic molecules and to make them like just amazing. So I'm going to be working through this a little bit. This is kind of the landing page as you land to MoleView. So it is moleview.org. I will be putting a link in the description as well. MoleView is a way of rapidly drawing your organic molecules. You can even get it to name those molecules for you as well. So pretty amazing. The landing page, as you come up here, it's just kind of talking about, will you donate to us? I highly recommend, if you've got some spare money, please do donate to them. It's pretty worth it. But let's have a look at what's going on here. As we arrive in MoleView, they've actually got a molecule of caffeine, which is pretty awesome as well. So on the left, we've got our 2D view over there as well. And we've got a 3D view over here. And here's the really cool thing. You can actually visualize your 3D, and the blue is nitrogen as a standard, oxygen red, carbon is gray, and then obviously our hydrogen in white. So this is really, really beautiful for visualizing what things look like in 3D. It will take the 2D drawing, the structural formula, and turn it into a 3D drawing. So I'd highly recommend you send this video to your teacher, to your friends in your study group, and actually get going with this. So what we're going to do is I'm going to show you how to draw this and just how to navigate inside this pane. You can do this on a smartphone as well. MoleView is mobile friendly, and that is the most amazing thing. So let's get going. I'm going to trash the caffeine molecule. I'm going to say goodbye to my morning coffee, and we're going to start drawing some molecules. Okay, so when I do draw, this is the one thing which I do like to switch on. I like to leave on the CH because, especially when I'm learning organic chemistry, I'm not used to the stick diagrams, because it's kind of nice to see where the atoms are. So I'm going to start out with a single bond, and we can start out with a single bond. You can rotate it however you want. Now, to add more bonds to this, all you have to do is click. And this is a really beautiful thing. So what I'm going to do is I'm going to draw 4 carbons over there and say, okay, all right, fantastic. And I'm going to add. And then what should I do? Okay, well, one of the things that we can do is we can just keep on adding carbons if you like. And if you go 2D to 3D, what it's going to do is it's going to try and update your molecule. Now you'll see that it's already saturated all of your carbons for you, which is quite nice. But if you don't like that, you can actually go in there and swap out atoms as you go. So this is one of the ways of swapping out your bonds. Now it might complain a little bit. Any bonds which are not completely full, it will fill up with hydrogens itself. We've actually got a really neat molecule over there. So there we go. Let's just change those back to hydrogens. So when I start drawing new bonds on this, here's the really cool thing. I can change them all to hydrogen. And this is the most amazing thing. So this is a really, really nice way of drawing molecules, and you can actually get them into your 3D view. That's looking a little bit messy. So what I'm going to do is I'm going to undo, which is an amazing thing that you can actually do over here. And I can say, okay, right, well, I would like to join that over there. Oh, a little bit too close. It's got snapping on. And we are going to join that on there. Let's see if it'll actually let us. No, it's too close. So what we can do is we can actually navigate in and move around with your scroll wheel. And that's the really beautiful thing. I'm not meant to be joining those carbons over there. But here's the really cool thing. So all I've got to be able to do is say, fantastic. It's saying sometimes it's inaccurate. It's just because it's doing bond estimation. It's trying to do VSEPR to try and estimate the 3D shape. So I'm going to say, don't show that again. It's a little bit of a pain. So I'm going to go 2D to 3D, and it's going to try and predict the shape. And we can actually see this beautiful shape that it's made here. So we can actually see this 4-membered ring there. 4-membered rings are really, really rare in organic chemistry. They're quite special. You generally won't find them. You can actually find like 2 of them joined on together in something special called cubane, because it's a cube. But you can actually start to visualize this stuff. That's the most amazing thing about this. So you can go in and edit these things. No more are you going to be drawing these benzene rings out. There we go. There's a benzene ring. For instance, if I want to draw the active ingredients inside, for instance, chocolate. So chocolate is phenethylamine. There we go. All right, there we go. There is a molecule. All right, so I need to change this to hydrogens. There we go. There we go. Nice. Okay, let's just saturate these guys. Saturate these guys. Whoops. We overdid it a little bit. Saturate you, and you. And I'm going to change this all to hydrogens. I'm sure you can automate all of this, but I'm going to ask you guys, once you've perfected this, to give me some tips in the comments below. But this is phenethylamine. Phenethylamine is the active ingredient inside chocolate. It is also the chemical which is present inside your first month of love with somebody. When you first see somebody, it gets you high. The problem is that it only lasts around about a month. And that's a bit of a problem because, eventually those initial infatuation feelings wear off. But then the really cool thing is, just to get that infatuation feeling back, all we have to do is eat a little bit more chocolate. It's got caffeine, it's got theobromine, it's got phenethylamine, the molecule which is on the screen as well. So let's actually just highlight this guy. Let's get rid of this really ugly one that we used to practice. Just delete key is really nice. There we go. So what we're going to do is do 2D to 3D. It's going to update. And there it is, guys. That is the love chemical. So that is phenethylamine. And you can actually start to see the shape. Now, if you're wondering if something is polar or not, a lot of you are. The really cool thing is you can say, okay, well, I'm not entirely sure which bonds are polar. We know that things further from the right and up are going to attract electrons towards it. So what we can actually do is, look, there's all these really cool tools. You can start to say, okay, well, I want to visualize this as van der Waals spheres, because that actually shows the size of the electron spheres as it orbits around. So that's your love chemical, looking all fat and plump. It's got some corona lockdown, extra weight. And what we can actually start to do is we can start to do all sorts of amazing things off here. We can actually do like bond dipoles or overall dipoles. So that tells me that there is energy or at least an imbalance in charge in those molecules, which is kind of balanced in the one way. And here we go. It's busy calculating, I hope. Let's see. Let's just change that back to a nice ball and stick. There we go. Ball and stick. Let's see if... there we go. Look at that. We've got an overall dipole in a particular direction. That is where the electrons are being attracted. I don't think that's particularly accurate because it's taking its cue from that nitrogen over there. There's actually a lone pair of electrons over there. But this is phenethylamine. Just to show you how versatile organic chemistry is and why I love it so much, we can actually alter these chemicals as well. So let's say, for instance, that guy. You'll see now what I'm busy drawing. There we go. All right, and there is dopamine. Dopamine is your motivation chemical. So I hope that if you're studying, you've got tons of dopamine in your mind. In fact, this is the chemical which is modulated or controlled by ADHD drugs. I'm ADHD myself, so I take medication which increases my dopamine. It's also a neurotransmitter which is affected inside Parkinson's patients. What else? So the medication which is taken for ADHD is actually pretty easy to construct. So what I can do is just highlight these guys. There we go. Let's say you, and you. I'm going to show you what the medication for ADHD is. It's coming up fairly shortly. And how are we doing? There we go. So there we go. That is a chemical formula for... let's go. Nope. Sorry, I'm getting a little bit carried away here. There we go. 1, 2, 3 hydrogens on that guy. Whoop. Still figuring this out. Let's see if it'll... no, come on. Right, let's see what we can do with all of that. We can actually leave that off. Hold on a sec. There we go. All right, so what we've got over here is a chemical which is called dextroamphetamine. Dextroamphetamine, you can see that the chemical structure is very, very similar. This is actually the medication which I take to control my ADHD. Now, it's not the same as methamphetamine. A lot of people say that methamphetamine is like so close to being the ADHD drug, and that is not entirely true. They say it's one molecule away. No, it is a molecule. It's a molecule away from anything else. It's the dumbest thing on the planet when people say something is one molecule away from something else. There is a part of the molecule which is missing. So the part which makes methamphetamine so strong is if you put on an extra carbon over there. I just showed you apparently how to make the stuff. So I don't know if YouTube's going to allow that. But there we go. Bam. Instantly, I went from an ADHD drug to something which can potentially ruin your life. So use organic chemistry really wisely. MoleView is this tool that I'm busy using. Please go and experiment with it. Show it to your chemistry teachers. Impress people with your 3D views. Because what you can actually do is with your model is you can export it. Here's a really cool thing. So we can embed it in web pages. You can put this link inside your social media posts if you like, and it kind of spins around. There's an information card as well. Look at that. And it gives me the name as well. So if you're wondering what your chemical name is, MoleView will actually give it to you. Look there, di-methamphetamine. It's actually identified exactly what we've got over here. Super cool tool this. I cannot actually believe that this is a free tool. Please, if you've got a little bit of extra cash, do donate to these people. So if we are starting to rotate around this, we've drawn all these molecules. Absolutely fantastic. Show me in the comments what you'd like me to draw, whether it's TNT explosives or it's whatever, actually. Serotonin, which is your happy chemical as well. I've clearly got a lot of that today because I found this amazing, amazing tool. Please like, share, subscribe, you know, all the YouTube rubbish, because I'd like to make a lot more of these videos. I'd like to help you guys out, show you a bunch of really cool tools as well. So yeah, I'm going to leave the dangerous chemical on your screen. And there it is. That's absolutely amazing. So share this with somebody. I've shown you something highly illegal. I don't actually have any of this. I hope you don't either. But yeah, absolutely. It is absolutely amazing that you can... oh, I've gone back to the medication. So this is totally legal again. Let's just do 2D to 3D just to update it. Fantastic. All right, there it is. Yeah, share this with somebody else. So moleview.org. I will put a link in the description below.